A good day to all of you children. Today I will be discussing with you a chapter called circles. It is a very important chapter from the point of view of board examination, because in the 10th standard I.C.S.E. paper, two questions, one each from each section, that is one question from section A and one question from section B is usually asked from circles. So at least section A being compulsory, it is very important that you must know. On top of it, it is a very important and very interesting chapter, though some of you feel otherwise. Okay, so let me try to make it very interesting, very clear to you so that you can solve it and this fear of circles is gone. So today I will be dealing with the chapter 18 of concise textbook, which is the first part. It is given in two chapters. Okay, so chapter 18, circles. You are already aware of all the different parts of the circles, different terms, but still let us brush up once again and then we will proceed, the basics. So now a circle has a center. With reference to this point of center only, we draw the circle, and this circle, this is called the circumference of the circle. Okay, now any point on the circumference of or each point on the circumference of the circle is equidistant from its center O. Okay, so the circumference is this one, that is sometimes in mensuration we also refer to as the perimeter, that is the length of this circle or the circumference. This is the center of the circle. Now the line joining any 2 points on the circle, say A and B, this is a chord. Okay, now when a chord passes through the center of the circle like this, then it is called the diameter. Okay, and the distance from the center of the circle to any point on the circumference of the circle is called the radius of the circle. So this is the radius. So all these things are already known to you. You are learning it from smaller classes. Just to brush up, we have again revised. We will learn more terms. Now, till now, we have learned the center of the circle, the circumference of the circle, then the radius of the circle, that is the distance between the center and any point on the circumference of the circle. Then a chord is a line joining any 2 points on the circumference of the circle. A diameter is also a chord, but what is the difference? A chord which passes through the center of the circle is a chord. This chord AB is not passing through the center of the circle, so it cannot be the diameter, and the diameter is the biggest chord in a circle. Okay, then also the part of its circumference of the circle, say for example this AB is a part of the circumference of the circle. This is called arc of a circle. Okay, now this smaller arc, if it is the smaller part of the circumference, then it is called minor arc. Okay, and the bigger part, this part of the circumference, then will be called the major arc. Okay, so now the area bounded between an arc and a chord is called segment. Okay, so the space or the area between the chord and the circumference, and an arc. What is an arc? A part of the circumference, and this is called segment. So if this is one segment, this is the other segment. Now the smaller one is again called minor segment, and the bigger part is called major segment. Okay, So now let me just quickly go through all the terms that we just revised. Circle, this is its center, O we usually call it, we refer to it as O, and this is the center of the circle. The distance between the center of the circle to any point, say P on the circumference of the circle, is the radius. The line joining any 2 points on the circumference of the circle is called chord. Okay, a chord passing through the diameter of the circle, through the center of the circle, sorry, a chord which passes through the center of the circle is called the diameter. Okay. Now the relationship between diameter and radius is diameter is equal to twice the radius. Then we learned segments. Before that we learned arc. Arc is a part of the circumference of the circle. Now if the smaller arc is called the minor arc, and in comparison to it the other bigger one is called the major arc. So we can call this minor arc from here to here, and from here to here. Okay, this is major arc, this whole part, and this is a minor arc. And the space bounded or the area bounded, the region bounded between the minor arc, between any arc and the chord is called a segment. So this is the segment. Now the area bounded by the minor arc and the chord will be called the minor segment, and the region bounded by a chord and the major arc will be called the major segment. Now let us learn a few more properties which are new to you related to chords. There are many properties that we will be learning. Let us learn first the chord properties. So a chord is a line joining any 2 points on the circumference of the circle. So now under chord properties we will be learning 3 theorems. Okay, now for our convenience we may number theorem 1, theorem 2, theorem 3, but these theorems have no fixed numbering. You cannot refer to them as theorem 1 or theorem 2, but you have to only refer to them by the entire statement or by the entire statement of property of the particular property. So now for our reference we will call this as theorem 1. It is in our book in concise, it is given as theorem 4. Okay, so the number is not, as I told you, not fixed. These theorems are not numbered. Now the statement of the theorem is very, very important, because using these you will be proving many other, you will be using them, applying them in solving other sums. Okay, so whenever you use this as a reason, you have to write this statement on the right side in square brackets. Some children of course draw tabular column, statement, reason, that is also allowed, but only thing is it will waste little bit of time. So you can write the reason in square brackets. So I will train you how to write it, but first let us understand the properties, that is the theorems. Now theorem 1, for our convenience, as I am again mentioning, this number is not fixed. Now this says a straight line drawn from the center of a circle bisecting a chord is perpendicular to the chord. Let me repeat. A straight line drawn from the center of a circle bisecting a chord is perpendicular to the chord. So let me write the statement. A straight line drawn from the center of a circle to bisect a chord is perpendicular to it. Is perpendicular to the chord. Okay. Now, what does this mean? A straight line drawn from the center of a circle. So that means a straight line is drawn from the center of a circle. So let us draw the circle first. So O is the center of this circle. Now what is given? A straight line drawn from the center of a circle to bisect a chord. So that means a chord also exists. So let us take a chord AB. Okay. So AB is a chord. Now a straight line is drawn from the center of a circle to bisect a chord. Bisect a chord means what? It joins the midpoint of the chord. So let us consider M is the midpoint of the chord. Okay. So a straight line is drawn to bisect a chord. Okay. That means the straight line will pass through the midpoint of the chord AB. So that is what is given. A straight line drawn from the center of a circle to bisect a chord is perpendicular to it. So according to this, it says that if a straight line is drawn from the center of a circle joining the midpoint of a chord, it will be perpendicular to it. So that is what we will prove and we will show you, and this is true in any circle. So let us first see how it is. So we know what we have. We have a chord AB, we have a straight line OM, okay, which is bisecting the chord AB. In other words, M is the midpoint of AB, or AM is equal to BM. You agree? Why? Because M is midpoint of chord AB. So that means AM is equal to BM we have. Also, we know that OM is the straight line drawn from the center of a circle. So what all we know? What we know, we write it as given. So in this statement, what is given? First thing, O is the center of the circle. O is the center of a circle, that we know, that is given. Second thing, AB is a chord, we know. AB is a chord. Third thing we know, OM is a straight line bisecting AB. So OM bisects AB at M. This implies what? OM bisects AB at M implies AM is equal to BM. Now according to this, it says then OM will be perpendicular to AB. So we have to verify that. We have to prove that. Is it true or not? So now we will find out what we will have to verify, whether OM is perpendicular to AB or not. That is what this theorem is saying. Then the straight line drawn from the center of a circle to a bisecting a chord is perpendicular to the chord. So we have to see whether OM is perpendicular to AB or not. Now let us see the verification part. So that means what we have to verify or what we have to prove? We have to prove that OM is perpendicular to AB. So with all the given information, let us try to prove it. Now in order to prove, let us join OB and OA. Okay, so that we will write as construction. This is the same way you will be also writing when you will be solving other problems using these theorems. So what is construction? Join OA and OB. So what you add on to the diagram should be always in dotted lines. Now proof, or we can say we are verifying whether this is true. Now for that, let us consider the two triangles OAM and OBM. So consider triangle OAM and OBM. Now we are trying to prove whether these two triangles are congruent. We are verifying. If these two triangles are congruent, then we can see what happens to these two angles. Okay, so in triangle, now let us see in these two triangles, OA is equal, we know that AM is equal to BM. We already know that. Why? Because it is given M is midpoint of AB. So AM is equal to BM. What is the reason? M is midpoint of AB, which is given to us. Also, OM is equal to OM common. Okay. Now, A and B are any 2 points on the circumference of the circle. So, OA and OB are the radii of the circle. Radii is plural. Radius is singular and radii is plural. So, OB is the radius and OA also is the radius of the same circle. So, they both are equal. So, OA is equal to OB, radii of the same circle. Okay, so that means we have these two triangles are congruent by I.C.S.E test, right? So it follows therefore triangle OAM is congruent to triangle OBM. Okay, by which test? By I.C.S.E test. Three sides of one triangle are equal to the corresponding three sides of the other triangle, then they are congruent. This implies when once they are congruent, then these two angles are also equal. Okay, why? They are corresponding angles of congruent triangles. So that means angle OMA is equal to angle OMB. What are they? Congruent angles, corresponding angles of congruent triangles. Corresponding angles of congruent triangles. But AB is a straight line. So therefore, these two form a linear pair because 180 degrees straight line. So, but angle OMA plus, this is not P, this is B, OMB. Angle OMB is equal to 180 degrees. Why? Because AB is a straight line, or you may say they are linear pair. AB is a straight line, or you may say linear pair. So implies these two are equal and their sum is 180. So implies each one is equal to 90 degrees. So implies angle OMA is equal to angle OMB is equal to 90 degrees. So that means this is 90, this is 90. That means OM is perpendicular to AB. So what we have started with, a straight line drawn from the center of a circle but to bisect a chord is perpendicular to the chord. So OM is the straight line which is drawn from the center of a circle to bisect the chord AB. So therefore we have proved that OM is also perpendicular to AB. Is it clear, children, this first one?